Hello, welcome back. If you watched my previous video about the squeeze theorem, we talked about an example about how we can find what happens to sine of x over x as x approaches 0. And we talked about finding the area between of a sector, this green little area, as being between the area of the smaller triangle and the area of this larger triangle. And we kind of showed mathematically how we can show that the limit was equal to 1. So let's take a look at how we use this mathematically. This is what we call the squeeze theorem, or sometimes called the sandwich theorem. And what it says is, let's say f of x is unknown. I don't know what f of x is, but I know it's between h of x and g of x right here. I can find f of x by taking the limits of what I do know, f and g. So if I find that the limit of h of x is some number, and the limit of g of x is that same number, well, what does that tell us about f of x? It should also be that same number. And again, we saw that when we did our example for squeeze theorem. We said if we can find the limit of cosine of x was equal to 1, because we said that sine of x over x is between cosine and 1 over cosine. Cosine is approaching 1 as x approaches 0. 1 over cosine of x also approaches 1. Therefore, x sine of x over x also has to approach 1. So, very easy way to look at this. Now, so how do we apply this theorem? Well, here's what it says. Let's look at the two functions, x squared and negative x squared. We know that f of x, which is given by this function, x sine of x plus pi over 3, is between the graphs of x squared and negative x squared on the domain negative 1 to 1. We want to find the limit as x approaches 0 of our unknown function. So here we have it. So here we have f of x in red and g of x in blue, whatever. So we have two functions. So we have x squared and negative x squared. We know that x sine of x plus 3 is between the two graphs on the domain negative 1 to 1. So I know it kind of looks, I can write it kind of like this. Wiggle, 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 wiggle. So here's f of x. Well, graphically, if I look at my parabolas, both my parabolas, x squared and negative x squared, as x approaches 0 on both of them, notice both of them are both approaching 0, the y value of 0. So what does that tell us about our function, f of x? Well, it should also be 0 because it's between them. But how do we write it? Very simple to do. We would say that f of x has to lie between negative x squared and positive x squared. And I just take the limit, and this is what we're going to do. I want to find the limit, so I'm just going to take the limit. So I would say, rewrite these as a limit problem. Take the limit as x approaches 0 of negative x squared, it's 0. The limit as x approaches 0 of x squared is also 0. Therefore, well, what does that tell us? Well, the limit as x approaches f of x, which is this x sine of x plus pi over 3, also has to equal 0. Because if both my outside functions equal 0, then my inside function also has to approach 0. And we're going to put down why this is. This is, of course, by squeeze theorem. So try another one here. Pause if you can. Here we have an unknown function. It's between 2 and x squared plus 2. Now, really what we should do is we should write this as a limit. Take the limit as x approaches 2 of 2, less than or equal to, oops, should be 0, not a 2 there. The limit as x approaches 0 of f of x, less than or equal to the limit as x approaches 0 of x squared plus 2. If we take the limit as x approaches 0 of 2, that's just 2. if we take the limit as x approaches 0 of x squared plus 2, if I plug in my 0, that's also 2. Well, my outside here is approaching 2, and my inside is approaching 2. So what does that mean for the inside? Well, it's sandwiched between them. So pick a number between 2 and 2, and of course it's going to be 2. Therefore, the limit as x approaches 0 of f of x is 2 by the squeeze theorem. You should say by squeeze theorem. And there we go. All right. Hope you enjoyed the video. I'll see you guys later. Bye-bye.